You're the acid in my coffee.
In this short video, I have the following 5 tasks. Task number 1, I'll discuss the definition of Durbin-Watson Test. It's related to autocorrelation. Task number 2, the formula for Durbin-Watson Test statistic. Task number 3, there are several critical values. Then starting from 3 value, 0 to 4. So this is from task number 2. Then how to get critical value, DL, DH. Then we have 1, 2, 3, 4, 5, 6. We have 7 values. 0, DL, DH, 2, 4 minus DH, 4 minus DL, and 4. 7 values. Then we have, based on these 7 values, we have 5 ranges. Task number 4, I'll discuss 3 hypotheses and their related decision rule. Finally, I'll give 2 examples. Task number 1, what is the Durbin-Watson test? The Durbin-Watson test is for autocorrelation. And it has a range from 0 to 4. 0 to 4. If 0, we have positive autocorrelation. 2, no correlation. 4, we have negative autocorrelation. Task number 2, Durbin-Watson test statistic or formula. Assume we have n error term. The Durbin-Watson test statistic is defined as dw summation ei, this is error term I minus previous error term with about 2 divided by summation of error term square. In the previous slide we mentioned if this dw is close to 0, it means we have a positive autocorrelation. If to the 4, then we have a negative autocorrelation. If it's 2, then we don't have autocorrelation. So let's assume we have some numbers. Okay, case number 1, 3%, the next one 3%, 3%, and 2.9%, then negative 4%, negative 4.1%, negative 4.1%, and negative 3.9%. So this is positive autocorrelation. So look at the first pair. 3% this year, next year. 3% this period, next year still 3%. So if you look at the difference, we have a 0 here. So this is 0, okay, because they are positive correlate, the difference is quite low. For the next pair, 3% versus 2.9%, the difference is also very, very small. So 0.001, and this is 0.001, the last one is 0.002. So based on these hypothetical values, we know if they are positive correlate, then this dw statistic should close to 0. So 0 for the positive autocorrelation. Let's look at case number 2, negative autocorrelation. Again, we have some hypotheses. Actually, we only just make them negative. Okay, 3% versus negative 3%. This is the first pair. I just replace positive with negative. Okay. Then we look at the difference. The difference will be 3% minus negative 3%, actually 3% plus 3%. So it's 2 times 3%. So let's look at the second pair. 3% versus negative 2.9%. So actually 3% minus negative, actually 3% plus 2.9%. So actually 2 times 3% minus a small difference, and continue this way. Okay, just pay attention to the value 2, 2, 2, 2. We always have a 2 here. Okay, so in a sense we have 2. Actually, if you look at this pair, it's simply 2 times error term square. Then we have a 4. So this is why if we have a very good negative autocorrelation, then the DW test should close to number 4. For case number 3, no autocorrelation. So let's generate some random number. We know if they are random number, then correlation is 0, or autocorrelation is 0. Click data, data analysis. Choose random number generation. Click OK. So let's generate 100. One column, 100. So let's choose from normal. Okay, mean is 0, standard deviation is 1. So if we choose the same random seed, then we'll get the exact same result. So let's choose 1, 2, 3, 4, 5. Output range, we are going to add the title. So let's start from A2. Click OK. So let's assume this is error term. This is error term. Then this is difference. EI minus EI minus 1. So this is this error term minus previous error term. So this is error term squared. D column is the corresponding B, actually is B column squared. So actually is error term minus previous error term squared. So this is start from second one. Second error term minus first error term or previous error term. Then we copy and paste. So this is C column actually is A column squared. So we start from here. A2 times A2 squared. We copy and paste. So this is, so D column is B column squared and squared. Okay, the Durbin-Watson statistic is simply summation of D column divided by summation of C column. So this is, that's called DW. This is summation of D column divided by summation of C column. A value of 2 is what we expected. Please pause this video to access the function or PDF file for the critical value for the DW test. For example, when alpha is 1%, the number of independent variables is 1 and the number of observations is 35. What are the critical values of DL and DH? Method number 1. If you are taking my course right now, just type .dw critical values. You enter 1%, 135. Then you'll get DL 1.195, 1.307. Method number 2. If no R, then issue one line error code. Otherwise, try the following link to get a PDF file. Here's method 1. If you are taking my course right now, type .get data. From here you see .dw critical value. Okay. If you want to know its usage, simply type dot critical, then hit enter. There are 3 inputs. The first one is alpha, its significance level 5% and 1%. The second input is number of independent variables from 1 to 20. The last one is number of observations. So this is example 1. When you enter the 0.01 for 20, it will give you, there are 3 possible hypotheses. Hypothesis number 1, correlation is 0. The decision rule is we have 1, 2, 3, 4, 5, 6, 7. We have 7 values. We have 1. So between 0 and the DL, positive autocorrelation, then inconclusive. In the middle, there's no autocorrelation. So actually we have 1, 2, 3, 4, 5. We have 5 regions. Hypothesis number 2, the autocorrelation is positive. For this one, we have 3 decision regions. Between 0 and the DL is positive autocorrelation, inconclusive, and no evidence of positive autocorrelation. And hypothesis 3 is opposite of hypothesis 2. So negative autocorrelation. From 0 to 4 minus DL is no evidence, and between is called inconclusive. The last one is negative autocorrelation. Please pause this video to get the VBA and the macros. Method 1. If you are taking my course right now, just type .c16. If you know R, issue the following codes. Otherwise, try following 2 links. To get the VBA, here I show how to use method 1. Type .c16. Here's VBA for Durbin-Watson Test. Okay. Use up arrow key 16, 15. Function and the function. So this is main function. The next one is help function. Just copy. Then we go to Excel. We click developer. Then we click VBA. On the left hand side, we click insert. We click module. Then we place there. Then we click file. Then close and return to Microsoft Excel. That's it. For this exercise, I'm going to generate negative correlate random numbers. Okay. First step, we type 1. The next one will be opposite of 1. So simply 1 times negative 1. Then we copy this formula up to 101. We are going to generate 100 such time series. So actually it's 1, negative 1, 1, negative 1, 1. Okay, continue this way. Next, I'm going to generate 100 random numbers. Okay, just click data, data analysis. We choose random number generation. And we generate 1 column. Okay, so this is 1 column. 100, we choose uniform. Okay, we have normal, we have, so let's try uniform between 0 and 1. And we choose a random seed if we want to get exact same set of random number. Output range, so let's choose B2. So this is location, the B2. And just click OK. So let's assume this is our error term, EI. So this is our error term. Okay, the error term is 1 plus, this is random number. Okay. So we have positive 1.03, negative 0.05, 1.1, negative 1.38. They are negative correlate. So this is will be the lag, I minus 1. This is will be a lag. So this is will be the previous error term. So let's calculate correlation. So this is CORR, and this is Durbin-Watson test. Okay. So this is CORREL. So this is error term, comma. Then this is lag. See, this is 92%, negative 90% is indeed, they are indeed negative autocorrelate. Okay, so let's calculate Durbin-Watson result. Okay, Durbin-Watson without calculation, we should know it should be close to 4. Okay, so this is DW test help. Okay, it is simply we enter DW test error column. DW test. Okay, so this is our error column. It's 3.19. Okay, then we can test whether it is significantly negative autocorrelated. The correlation coefficient is negative 92. So here is negative 92. So next, to see whether we can control this value. Okay, so let's copy these two. Okay, we copy as value. Copy as value, so we keep this positive 1, negative 1, and the correlation. So we add a scale. This is scale up our random number. So let's use scale. Let's use 1. So actually, this is replicate this result. Same as before. So let's assume this is error term column. Okay. So this is 1 plus. So this is error term we scaled up by this value. Okay. Now it's 1. We are exact same thing. So this is 1.03. We have 1.03. We have the same value. Then this is like the lag of error, same as before. So this is previous error term. Then we just copy and paste. Okay. And so this is correlation or coefficient, CORREL. So this is error term column. And second input is lag column. We have the same result because we use them. Obviously, for the Durbin-Watson test statistic, we should get the same result. It's DW. We apply the same function, DW test. Then we highlight the error term column. exact same result. I'll use purple. Now let's look at the impact of scale. Okay, the scale now is 1. So if we scale it up, so this is mean the error term will dominate. Because the error term will dominate, the correlation coefficient will be less correlated. Durbin-Watson test statistic will move towards 2. So let's scale up to 10. So before is 92%, negative 92%, now it's negative 0.4. Okay, the Durbin-Watson test statistic is only 0.64. So let's copy them as a value. So this is for scale. Scale of 10 is scale up. So let's use 20 or 50. Then even smaller. Okay, so this. So let's copy paste again. So this is for the 50. So let's scale it down. That's 0.1. Then our expectation is error column will be dominant. Then this test statistics actually close to 4. You see, this is when scaled down the random value. So this is 0.1. This will be our second result. We have chicken and eggs, as we discussed with another video. Okay, chicken and eggs. Then we have some leg. So this is chicken leg 1, chicken leg 2, and chicken leg 3. Similarly, for the eggs, we have 3 legs. So actually, we are going to run a regression. So this is y, dependent variable is y, against 3 legs for chicken and 3 legs for the eggs. Then we conduct Durbin-Watson test their residue. Okay, so we click data analysis, and we click regression. Okay, for the y column, so we enter chicken. Control Shift and down. For the x column, we enter 1, 2, 3, 4, 5, 6. We're going down. Control Shift and down. Then we check the labels. Then we output here. Okay, here is important residue, because we need a residue to calculate Durbin-Watson test statistic. Then we click OK. Again, here is residue. So let's calculate Durbin-Watson test statistic. So this is DW test. So Control Shift down. Then we close it. The Durbin-Watson test is here. It's so close to 0. Sorry, it's so close to 2. Then we are going to calculate the critical value. Okay, the critical value, so how many observations, suppose we choose alpha is 1%. So this is how many independent variable? 1, 2, 3, 4, 5, 6. We have 6 independent variable. How many count? How many observations? Control Shift down. Enter. Okay, we have 3 values. Okay, so alpha is 1%, and number of independent variable is 6. number observation is 51. So let's find the critical value. Okay, so we go to R, we simply enter 1%, sixth, so this is 51. So this will be our critical value. This is a macro to show our result. On the right hand side, we have step 1, step 2, step 3, and continue this way. You simply click step 1. See, we enter critical value. We enter Durbin-Watson Test statistic. From previous exercise for chicken and eggs, we know it's 1.1318. So this is low critical value. DH is 1.6388. Our Durbin test statistic is 1.98. It's 1.98735. So we only need these three values. Then we click step 2. So we add 0, 2, and 4. We click step 3. We enter. So these are all labels. Step 4. And so we have DL, DH, 2, and 4 minus DH, 4 minus DL, and 4. Okay. Then we add the value. Okay, we add the value. So we simply color them. Okay, so this is 1.1318 from here. So this is 1.388 from B2. So this is will be 4 minus B2 and continue this way. Okay. Then we can add the words. So the first one is a positive autocorrelation. So green is no autocorrelation. This is negative autocorrelation. Question mark are inconclusive. Okay. Finally, we add our words. Okay, 1.3897. Okay, so our conclusion is no autocorrelation. Okay, so actually when we change the value here, suppose we 3.4, it will automatically jump to here.
You're the acid in my coffee. You're the fluid in my lungs. Your memory's a poison. It's